Thank you for joining us this Tuesday in a webinar with SmartBear and Meghan Munseeney, who is a software engineer at Yesware, and she's going to be talking about achieving quality without a dedicated test team. So she's going to be talking about Yesware's quality process and what that looks like at a company where they don't really have, a designated QA team like some other companies may have or organizations might have, and hopefully give you, the listeners, some tips on how you can have a bigger hand in quality no matter what your role is. So without further ado, I'm going to hand it over to Meghan so she can get started.
Okay, hi everyone. Thanks Alex for the introduction, and thanks SmartBear for having me today. As Alex mentioned, today we're going to talk about achieving quality without a dedicated test team, specifically from the lens of the Yesware development process. Before we get started, I'd love to give you a brief introduction about me, so you know who's talking here. I'm an engineering team lead at Yesware. I have a little bit more than 16 years of software startup experience. I have a little bit more than 12 years of experience in testing and test engineering. And about 4 years ago, I transitioned full-time into software development. And about Yesware. Yesware is an inbox productivity platform for salespeople. We help enable authentic email communication at the scale required by today's business environment. You can find us on the web at yesware.com, and feel free to tweet at us at Yesware. This webinar will cover several examples of maintaining quality and the role of quality that occurs outside the realm of what we would consider testing performed by a traditional quality assurance team. I've broken this down into 3 areas: the software development process, the software deployment process, and production or customer feedback. We'll have time for questions at the end. A few caveats about this. This talk is about avenues to quality achieved via Yesware's development lifecycle. It's not a recommended replacement for test engineers or a dedicated test team. Every organization is different. Everyone has different needs. Regardless of this, testing and quality are organization-wide concerns. And lastly, just like everyone else, Yesware is neither bug-free nor incident-free. So when we talk about quality at Yesware, it's really important to set the stage and discuss the structure of our teams. We have 2 to 4 software engineers on each team. We have no dedicated test engineers, no dedicated DevOps engineers. All engineers are able to test, deploy, and manage their code and their team's code. There's no wall between engineering and test. And the additional team members that play a role are a designer, a product owner, project manager, a team lead, and an engineering manager. The downside of us not having test engineers or DevOps engineers is that it can lead to a lack of ownership and specialty when it comes to those 2 disciplines. One of the ways that we're able to achieve quality across the board is that we've switched from a monolith architecture to a microservices architecture. There are pros and cons to this, which I will describe on the next slide. But I wanted to provide a high-level view of this for folks who haven't worked in a microservices architecture before. On the left is a picture of a monolithic architecture. And basically, with a monolithic architecture, the business logic, data layer, and UI sit very closely together in a single application. In a microservices architecture, there are several backend services, maybe with their own database and maybe with their own UI, or perhaps they share a single UI connecting to different backend services. And as I mentioned, there's pros and cons to a microservices architecture. Some of the pros are that it can isolate functionality, mostly, which I will describe in the cons section. It provides the ability to utilize new or different frameworks and tools. It forces some standardization. For example, you might standardize message passing between different services. You might standardize tools for creating new services. It facilitates upgrading dependencies. So for example, you could, we're a Ruby Rails shop, so you might try to upgrade Rails on a less important service to see what kinds of things you find before you upgrade something that's more business critical. It makes it easier to manage code conflicts since you don't have developers all working in the same code base. Makes it easier to deploy, isolate problems, recover, and scale. Some of the cons are that it can be difficult to refactor legacy monolith functionality. When I mentioned that it isolates functionality, and in parentheses, mostly, transitioning from a monolith to a microservices architecture can be really difficult, and you can find yourself with old legacy functionality kind of sprinkled throughout your services. There can be a high overhead to automating end-to-end tests. There's a higher cognitive load, meaning that sometimes you're struggling to figure out where functionality lives, where you should add new functionality, how does this new framework behave, how does this old framework behave? And of course, then there's also the added complexity and functionality of managing inter-service communication, either through message passing or even things like authentication. On the subject of automated tests, we tend to follow an 80%, 20%, or 90%, 10% rule of unit tests to end-to-end tests. We tend to unit test with RSpec and Jasmine, and we try to unit test as much as possible. The goal is to achieve 100% code coverage, which we realize is not always realistic. You might have things like database indexes in your code that you would never want to write tests for, or you might have support code, test code that you don't want to write tests for. So the coverage report generated during a test run would let us know where the holes in testing may be. And the coverage threshold in a microservices architecture is set on a per service need to accommodate those needs of the particular service. If we find that a coverage is below the desired threshold, the code will fail to pass a code review process. And at that point, we determine, oh, do we need to write more tests, or do we need to talk about what is a reasonable amount of coverage to have for this service? When we do perform end-to-end tests, we mock unrelated or unnecessary services that might cause flakiness or may be difficult to maintain over time. This is an example of how we might mock a service we aren't testing. Similar things can be done with tools like Protractor and Jasmine. If we're finding that something causes a lot of flakiness, or if it's hard to maintain, we question its efficacy. We also have to question tests efficacy if it won't run in a continuous integration system. Once a developer has written their features and their tests and they're pretty happy with where things are, we require that developers manually end-to-end test on their own development environment. If the changes are pretty critical or they might touch several subsystems, we might require a staging test for that piece of functionality. Staging is the best mirror to production other than testing in production. And so for those critical pieces, staging is a good place to do those tests. The last kind of review we do before we even submit a pull request for review is that we'll perform a design review. If there's UI elements that go along with a pull request, we'll pull in a designer to take a look at what we've built before the developer submits a pull request for that new code. This really helps us to expose issues early on in the development process and to minimize changes in the midst of a code review or after it has already gone to production. Once we've gone through that manual test process and an internal design review, if it's possible, we submit a pull request. The code in each pull request is as small as possible so we can easily identify the potential point of failure, minimize the amount of code a reviewer sees, minimize code fatigue, and ensure steady feature progress. A clear descriptive summary of the changes, a reference to the issue number, and screenshots are provided for clarity of the change. Providing a screenshot or a brief video forces the hand of the developer to test out the change being made and gives reviewers context and a visual along with the code changes. We also require passing tests to merge a pull request. We run all of our automated tests via TeamCity. Any flaky tests or test failures are treated as a high priority item and must be addressed immediately. This gives the developers the confidence they need to augment features and refactor as needed. The third thing we do in a pull request is we pass code through code climate. This minimizes typos and provides a high-level audit of the code by an appropriate code linter. This helps developers to catch programming errors quickly and to help reviewers be able to focus on the essence of a change. Once everything has passed tests, code climate coverage, we choose two reviewers as a peer review of the pull request. We must require at least one sign-off from a peer reviewer. We choose these reviewers to minimize flyby reviewers and added confusion. The screenshot we see here on the right shows what GitHub looks like for Yesware. We leverage GitHub webhooks for our issue tracking software, our continuous integration software, and code climate, so we can easily see the state of a pull request. These checks also provide the added benefit of a quality audit of the pull request, so you can review what happened after the fact. Once a specific pull request has been approved, it's time to deploy that code. As soon as code is merged, engineers are responsible for deploying the new code to production or other providers. That might be Heroku, Chrome Store, GemFury, NPM. Every engineer is able to deploy every service or library at any time. Because the changes between deployments are isolated via microservices and the code changes are small, we are able to find and fix or revert problems quickly without affecting other areas of the code base. As you can see from the screenshot we have here, we leverage Slack for timely and public updates. We have a link to the GitHub pull request, the essence of the change with a ticket number, who it was deployed by, what service it's associated with, and the time that it happened. Once that deployment has gone through, the developer must manually test it again in production. And once again, we involve product and design once anything goes out. Product and design will review it again. One of the ways we're able to isolate functionality is through our internal availability system. We use internal availabilities to limit the rollout of features. We can enable for Yesware employees a set of user IDs, email addresses, or domains. We can enable it for a percentage of users. We can disable it for a list of emails or domains. And Yesware colleagues are always the first customers. The benefit of our internal availability system is that it enables engineers to develop features gradually. We can test or build a half-baked feature behind an availability to understand quickly if we are moving in the right direction. It helps us to know early on with limited scope if there are common issues affecting internal users or a subset of users. It allows product to be able to obtain early feedback from beta users. It facilitates feature rollback if a major flaw is discovered. And again, as we've done also with our deployment process, we've integrated with an internal bot to let us know through Slack when a feature has begun rollout, who it's gone out to, and what that specific feature is. So we always have an audit of changes. Once code is in production, we of course have to monitor it. We're monitoring with different kinds of monitoring tools. And if we discover an issue, we have a seamless rollback and revert process. So we leverage Heroku's rollback, and then we immediately revert the change in Git and redeploy. We always revert and redeploy immediately so that code is always deployable on top of master. And again, we leverage Slack. We leverage Slack for timely notifications from our escalation system. This helps with documenting when an issue occurred, when an issue was resolved, and who is tackling that particular issue. And now feedback. So code is in production, customers are using it. And like with any feature, there will be things that come in, either enhancements or issues. And software engineers are involved in that process in two main ways. The first is what we call escalation zone. What that means is one engineer per day is in the escalation zone. We can receive up to 4 issues from our customer success team per day. It has the benefit of maintaining a closeness between the customers and the engineers. And anything repetitive, bugs, or tasks we find ourselves doing are prioritized as work to be done. It also has the benefit because engineers can have the autonomy to resolve small bugs quickly, and they can understand intimately the kinds of issues customers are facing. The other way we're involved in a production customer feedback is through an on-call rotation. Since we have no dedicated DevOps team, all engineers are expected to be on call. We're on call maybe once every month and a half to 2 months. There are 2 engineers on call per week, and anything repetitive automatically becomes a high priority issue. This helps us maintain the truthiness of the alerts. It also has the benefit to expose all engineers on the team to pieces of the system that put an application together beyond their own code. In wrapping up, I have 4 main points that you may want to try to include in your own process. The first is to consider the state of your team's automation tests. Invest in a system like Jenkins, TeamCity, Travis. Run all the tests on a continuous basis, and if they're not able to do that, let them go. If you aren't set up to do something like pull requests via GitHub, you could run your tests nightly or hourly on the master branch, and then leverage hooks between tools to open communication beyond the development team so that people know what's going on. The second is to try to achieve a cadence of deploying code immediately and often. Deploying code immediately provides the comfort that the change being made is small and intimately known. Issues that arise after that change can be quickly discovered, resolved, or averted. The third point is to empower development teams to find and fix tests and operational issues. Developers are responsible for more than just their code. Enabling the development teams to be closer to the customers using their code increases the chances that issues with their team's code will be discovered, prioritized, and addressed. Allowing development teams to tune operational alarms and address operational issues will drastically reduce on-call fatigue and the overall performance of the app. Allowing developers to prioritize and fix flaky or failing tests drastically improves the overall quality of the test suite over time and gives developers the confidence they need to add new features and refactor. And the last point is to implement a formal internal review process with other developers, design, product, and other stakeholders. Allowing for an internal review from a variety of stakeholders can increase the possibility of discovering issues from folks with different interests, different use cases, different mindsets, and thus increasing the overall quality prior to releasing to external users. That's all I had for today. I think now we'll open up for questions.
Yeah, so everybody, we're gonna hop into our Q&A section. So I'm sure that you have a lot of questions for Meghan about some of the stuff that she just talked about and maybe how it applies to your own organizations. But first I wanted to open up with a question for all of you. So maybe if you wanted to put in the chat box down at the bottom what your role is on your team. Do you have a QA team? What does it look like? How big it is? But, definitely put your roles in there, what you do on your team. And then feel free to head into the chat, the Q&A box, and answer or ask Meghan some of your burning questions that you probably have after this webinar. And we'll wait for a few of those to come in and then start answering them. So go ahead. Okay, so Meghan, it looks like you have one in there if you want to start with that one.
Yeah, sure. So we primarily use Jira. One thing that I didn't talk about in this presentation is that we follow something more closely to Kanban if we're talking about agile methodologies. And what Kanban is more of a just-in-time model. So we have a constantly reorganized backlog that the team leads and the product owners are constantly reprioritizing. The stuff that's on our board is the high priority stuff to work on. And we use a Jira board for that. And then the backlog is all stuff that we will be doing soon. And like I said, we're constantly reprioritizing those items.
All right, so a few people are putting their roles and what their teams look like in the comment box. So definitely keep that coming, and then also keep your questions coming as well. Oh, here's another one.
So the question is, how can QA teams test efficiently without getting in the code too much? Well, I would say there's different benefits to different styles of testing. There's manual testing, there's load testing, there's automated testing. I'm a big fan of exploratory testing. I think that is one of the most efficient ways to test without getting into the code. And basically that means that you're acting as the end user. You are aware of the changes that have happened since the last time you were in the system. And so kind of using the system as an end user, starting simple and getting to more and more complex in the way that the user might use the system. I think that test cases can be a little bit too rigid, and I think it makes it so that testers can miss things along the way. But I do encourage all testers to try to get involved in some automation. And that doesn't necessarily mean looking at the code of the application you're testing, but understanding how that application might be tested in an automated fashion. The next question is, do you have automated UI tests, and which tools do you use? We do have automated UI tests. We tend to use Jasmine for most everything. That's a JavaScript-based tool, mostly unit testing, but it can do other things. There's another tool that we've used called Protractor, which allows you to do a little bit more of an end-to-end test, but you do have to mock out services if they're not available to you at the time that you're testing. Of course, you could set up a test that's required where all the subsystems start up as part of that suite. The other thing we've done is RSpec and Selenium. We've done a lot of end-to-end tests using those two tools as well. The next question is, I'm curious as to how long it takes to get automated test feedback. Do you set hard limits on that? Have you dealt with test execution times getting longer and longer? So for the first part, another benefit of having microservices is that you can have your tests isolated to those microservices. And so that also minimizes the number of tests that you're executing at any one particular point in time. With our old monolith app, we have not set hard limits on that. We're probably upwards of an hour of all tests there. That includes unit tests. It's probably, I want to say 25 minutes of more end-to-end type tests on that monolith app. And frankly, that is one reason why we moved to a microservices. That's one of many reasons we moved to a microservices architecture, is that waiting for builds to end was just taking too long. And so getting that feedback loop shortened was really critical for us. And as far as dealing with execution times getting longer and longer, that certainly is a problem, especially if you stay in a monolith type of architecture. One thing you could do is maybe segment tests out into a specific feature area. Maybe you always run a smoke test if you wanted to, or maybe there's tests that you could just run on master, or maybe there's less critical tests that could be run in a different way. But it certainly is something to consider. I think the shorter those run times are, the better. The next question is, do you use the same process for any issues coming back from production post-deployment? Hopefully I'm answering this question appropriately. We use a different system coming back through customer success. I don't completely recall the name of that system, but what ends up happening is the customer success team submits issues into Jira for us to work on. Use the same process for any issues coming back from production. I guess I would want clarification as to what the process is, like which part of the process are we talking about there? Is it possible to get clarification on that question?
Yeah, if you would like to just follow up that question, I'm not completely sure how to say the name, but Sadia, if you'd like to follow up on that question, so Megan can better help answer it, then yeah, feel free to type another one in that box, and then we'll just move on to the next one for now.
Okay. How do you ensure developers understand test heuristics and know how to test well? What if they don't like or want to test? Those are really good questions. I think for more junior software developers, it takes some coaching to help identify different scenarios that are going to happen. And a lot of that coaching happens within the pull request process. And perhaps that should happen earlier for us. But a lot of that happens there in terms of us asking questions like, oh, have you tested this scenario? It looks like you don't have a test for this. And we also talk a lot about, depending on the feature, we might talk about what kinds of tests don't really make sense for the feature that is being built. So the short answer of it is it takes coaching, and a lot of it is happening within our pull request process. If they don't like or want to test, my frank answer is that they might want to work in a different environment, like maybe consulting or something different other than working on a software development team. Testing is just part of the gig, I would say. The next question is, does your dev team create a test suite that they share with the QA team? We don't have a QA team at Yesware, so the answer to that is no. But if we did, then yes, we would. It would be a shared suite amongst everyone. We don't really have the notion of mine and theirs. All the code is completely shared between all of the teams. And we don't have a single test suite. We have probably several dozens of test suites, depending on the microservice involved. The next question is, how do you handle new or smaller projects? Do you still do unit tests and automated tests, or do you avoid them because the site will change significantly each time you commit code? That's also a really good question. It really depends on the nature of what we're doing. If we're doing a proof of concept, then no, we would not require unit tests or automated tests. If it's a new project that we know we're going to build and roll out to customers, yes, we will write unit tests. We may not write an automated test, meaning we may not write an end-to-end test. And the reason for that being, just like you said, things are changing pretty significantly. But unit tests are critical, especially if we end up keeping that newer, smaller project around. You want to be able to refactor. And if it's going to customers, then we want to have that confidence. We may wait to write an end-to-end test until it's actually in the hands of more customers. Who builds, maintains your unit tests and automated tests? Are both of them handled by the developer who wrote the code? All of the software developers build and maintain the unit tests and automated tests. If you're adding a new feature, you're responsible for writing the tests that go along with that. If you're augmenting an existing feature, then you're responsible for updating those tests or adding to those tests. And so the answer is that it's handled by both the developer that wrote the code, and it's also handled by the developer who's updating the code. The next question was, did you have testers in your organization previously? If so, what happened to those people? Did they transition to development as you did, or did they move to other parts of the company? We've never had a dedicated test team. Yesware tends to hire what we like to call T-shaped people, which means that you have depth in one particular area and maybe breadth in a lot of different areas. And so from a test engineering background, that's me. And we also have somebody in-house who has deep DevOps background. And then we have some folks who have a lot of knowledge about front-end frameworks and building UIs. And then we have some folks who are more back-end heavy, and then other folks who are full stack. But everyone is kind of expected to be able to switch to other contexts. So to answer your question more directly, we have never had a test engineering team. And for me, when I first started at Yesware, our test automation was in a bit of a mess. We had kind of confused development environment and test environment in some ways. We had a lot of tests that were really flaky. And so when I was first hired, I cleaned up all of that. And then a year later, transitioned completely into software engineering.
Alrighty, so it looks like you've about answered all of the questions. If anybody has some last minute burning questions on their mind, feel free to do it now. But otherwise, Thank you, Megan, so much for joining us today and talking a little bit about what it looks like to be a software engineer at Yesware, and how you guys advocate for quality and your experience with that. Hopefully this was really interesting to people. I know I found it really interesting. And anybody that registered for the webinar today and joined us, you will be receiving a recording of the webinar and a follow-up email after. So make sure to look for that, and then check out some SmartBear tools. Like I'm on cross-browser testing, and we have UI testing tools for developers, testers, and teams of all sorts. So thank you everybody again for joining us today, and have a great day. And thank you, Megan.
Thank you so much. This was great. And thank you for all the really wonderful questions.